Hello sir, I'm Bharatrash Madhavan. My metric number is A20A1284. I would like to begin our group presentation with introduction. First of all, statistics is a branch of mathematics dealing with data collection, organization, analysis, interpretation, and presentation. Statistics deals with every aspect of data, including the planning of data collection in terms of the design of surveys and experiments. Thank you. Then I would like to continue with 1.0, which is data description. Based on dataset B, there are two types of variables, which is numeric and string. In that case, the variables under numeric variable are price, weight, length 1, length 2, length 3, height and width, while under string variable include species and place. Then the place of fishes analyzed, these include Singapore, Canada, Turkey, Malaysia, Vietnam, USA, Ireland, Britain, Norway and France. After that, the types of fish, for instance, smelt, stingray, roach, perch, pike, cod, and bream. In that case, our group has given a data with 159 observation of 7 types of fishes captured at 10 different types of countries with the price of the fishes is 2.0, which is the sample data. These are the randomized 60 observation from the dataset B using IBM SPSS statistics. Our group used this sample data to complete this report.
My name is Fatina Bila binti Ismail. A20A1342 is my metric number. For this slide, I'll show about mean for the price. Firstly, mean is the average you are used to from the selected data. The box on this top of slide is the data after we find it into frequency, midpoint, and fx. Means formula is shown in the next box. We take the total of fx divided by total at frequency and we get the value is 379.31. Next, followed by median, which is second instrument for measures of central tendency. We get the median at 30 observation and the median class is from 167.08 to 332.45. After we get the lower boundary, class width, and the following as shown in this slide, we can calculate the value using the formula. So, the median for price is 379.31. The model class is recognized at classes 1.71 to 167.08. The lower boundary 1.7. The difference between the frequency of model class and the frequency of the class before model class is 90, and the difference between frequency of model class and the frequency of the class after model class is 5. Using the above formula format, we'll get 226.14 for prices mode. To determine the measurement of position, the data must be sorted from lowest to highest. The different measures of position, quartiles, meaning to divide the data set into 4 equal parts. There's formula for step 1, which is to calculate lower quartile, and second step for the third quartile. In this data from price, 41171 and 592.34, respectively for Q1 and Q3. We can get the value for interquartile range, which is 180.63. For the measures of valuation, according to the box which have total of fx, which is frequency multiple with midpoint, and total of fx power of 2, as shown in the box which is 1361549.29. So we'll get range 992.26, variance 84454.46, and standard deviation 290.61.
My name is Nurul Aiba binti Muhammad Kamaluzan. My metric number is A20A1846. So for numerical frequency, I will describe about the variables of weight. As usual, they have mean, median, and mode for the measure of central tendency. So the answer for mean of weight is 444.53. The median of weight is negative 275.05, and the answer of mode of weight is 200. After that, the measure of position of weight. Based on this table, we have used it to find the interquartile range, where the answer for that is 402.68 by follow the formula. Then, the measure of variation of weight variable. From the table, we have to calculate one by one to get the total of x squared, fx and fx squared. After getting all the answer from this table, we have to find out the answer of sample variance first, which the answer is 1,892,746.93. Then we use the sample variance answer to find out the sample standard deviation. By following the formula, we managed to get the answer of sample standard deviation of weight variables. So the answer is 1,375.77.
The measures of central tendency is a single value that attempts to describe a set of data by identifying the central position within that set of data. The mean, median, and mode are the all valid measures of central tendency. First of all, the mean. The mean is the average of your used to where you add up all the numbers and then divide by the numbers of numbers group. So the calculation of the mean is equals to total fx divided by the total frequency. Therefore, 1661 divided by the 60. So the mean is 27.6833. The next is the median. The median is the middle value is in the list of numbers. There are 5 steps. First of all, step 1 is find the observation. That is second in the second position. In the second position, that the median class is 23.3 to 37.2. The lower class, second step is find the lower class boundary, that is 22.8. Step 3 is find the class width, that is 14.9. Step 4 is find the cumulative frequency before median class, that is 24. So step 5 is the calculation. From that we can get the mean, that median, that is 26.525. The next is mode. Mode is the value of that occurs most often. There are 5 steps. Step 1 is find the mode class, that is 23.3 to 37.2. Step 2 is lower class boundary of the model class, that is 22.8. Step 3 is the class width, that is 14.9. Step 4 is the difference between the frequency of model and the frequency of the class before model, that is first difference is 2, second difference is 19. So therefore step 5 is the calculation. So the mode is 24.22. The next is measures of position. So there are 2 steps, that is find the location of Q1 and Q3. Q1 is 15, the class interval is 9.3 to 23.3. Q3 is 45, the class interval is 37.3 to 51.2. Step 2 is the calculation in Q3. First thing is Q1 is 18.5625. Q3 is 814.357. So therefore we can calculate the interquartile range, that is 795.795. Lastly, the measures of variation. First one is sample variation, that is 1480225. The second is the sample standard deviation, that is 11.668.
I'm Selvamani Annaprabhat Armugam, A20, A1935 is my metric number. This is a graphical representation, drawing. The use of initiative chart to effectively illustrate and simplify data is referred to as graphical representation. Data is observed into data software's graphical representation, which is then represented by a variety of symbols such as lines on a line chart, bar on a bar chart, or slice on a pie chart, from which users can obtain more understanding than from numerical analysis alone. Representational graphics can help predict and make better data-driven decisions by immediately illustrating general behavior and highlighting phenomena, oddities, and linkages between data pieces that could otherwise go noticed. The type of representational graphic that are utilized will be determined by the type of data that is being investigated. This is the length, and also this is the calculation of the length, which is arranged by class, frequency f, midpoint x, and fx. This is our length graph, length calculation with the frequency polygon graph. This frequency polygon shows the length of features captured at several places and labeled with midpoint, which is centimeter cm. In this frequency polygon, y-axis refers to the frequency number of features, while x-axis shows the length of features in cm. Based on the graph, The highest frequency number of fish is 26 with midpoint of 30.25 centimeter. Meanwhile, the lowest frequency number of fish is 3 with midpoint of 58.25 centimeter. This is our price calculation, which is arranged by classes, frequency, midpoint, and FX. And also, this is our histogram uh, graph, which is for the price. This histogram illustrated the price of fishes captured at several places and labeled with midpoint, which is the Ringgit Malaysia RM. In this histogram, y-axis refers to frequency number of fishes, while x-axis shows the sales of price of fish. Based on the graph, the highest frequency number of fish is 19 with midpoint of RM 84.385, and the lowest frequency number of fish is 4 with midpoint of 745 9.905.
What is 5.0, which is statistical analysis using software? Firstly, for length 1, in manual calculation, the mean is 27, the median is 26.525, the mode is 24.22, the range is 37241, the variation is 1480225, the standard deviation is 11.668. While in SPSS output, the mean is 2.82, the median is 3.00, the mode is 3, the range is 3, the variation is 695, the standard deviation is 833. Finally, for price, in manual calculation, the mean is 379, the median is 379.71, the mode is 226.14, the range is 992.26, the variance is 84454.46, the standard deviation is 290.61. While in SPSS, the mean is 3.78, the median is 3.00, the mode is 2, the range is 5, the variance is 3.088, the standard deviation is 1.757. For weight, in manual way, the mean is 444.53, the median is negative 275.05, the mode is 200, the range is 1650.0, the variance is 1892746.93, the standard deviation is 1375.77. While in SPSS, the mean is 3.12, the median is 3.00, the mode is 2, the range is 6, the variance is 2.071, the standard deviation is 1.439. After that, based on the graph frequency polygon of length 1 by manual way and in SPSS, the title is same as the length of fishes captured at several places, and the y-axis is also same, which is frequency, but the x-axis is different, such as in manual way it refers to the midpoint, while in SPSS it refers to the classes. Lastly, based on the histogram of price from two different way, which is in manual way and in SPSS, the title of both graph is same as the price of fishes at several places, and the y-axis is also same as frequency, but for the x-axis it's different, such as in manual way it stands for midpoint, while in SPSS is classes.
Nabila will continue again for hypothesis testing. One sample t-test. In this example, we will determine if the mean of prices of fishes that have is greater than 370. The box shows that this data have 60 observations. The mean of a price of fishes is 374.7588, and the standard deviation of the prices of fish is 316.0291. The standard error of the mean is 40.7991. So, we fail to reject HO. That is, there is insufficient evidence to conclude that the mean number of prices of fishes for the species of fishes is larger than 370.
Now I will describe about correlation analysis that our group has done. So as we can see here on the left figure is a scatter plot, which is a metric scatter plot. It is used to describe the bivariate relationship between the combination of variables we use, namely price, weight, and length. Each distribution plot in the metric describes the relationships between a pair of variables, allowing many relationships to be explored in one chart. So for the graph 1, plots length against the price. It shows that the strong relationship between the two variables. For the graph 2, plots length against weight. That means it shows the higher length, the higher weight. Therefore, there are positive correlation between them. While graph 3 plots price against weight is show positive correlation between two variables. Next, for the table on the right side, show the correlation between three of them: price, weight, and length. The correlation between price and weight is 0.971, which is positively correlated, and the test shows significant relationship. That means the strength of correlation is strong. The correlation between price and length is 0.903, which is positively correlated too. The test shows a significant relationship between two variables. Furthermore, the strength of correlation is strong. The last one is correlation between length and weight is 0.924, which is positively correlated, same as the correlation between price and weight and price and length. The test show a significant relationship between these two variables. Furthermore, the strength of correlation is also strong.
The next, I'm going to explain about the confidence level analysis. A confidence interval depicts the likelihood that a parameter will fall between two values near the mean. The degree of uncertainty or certainty in a sampling process is measured by confidence interval. They are often built with confidence level of 95% or 99%. So we can interpret this result by saying we are 95% confident that the mean score for confidence in the price of the all species will fall between 317.2885 and 411.1182. The next is we can interpret this result by saying we are 95% confident that the mean score for confidence in the length one of all species will fall between 24.681 and 27.813. The next is we can interpret the result by saying we are 95% confident that the mean score for confidence is the weight of all the species will fall between 342.254 and 454.398. So the conclusion, if the null value is included in 95% confidence interval, there is no statistically meaningful or statistically significant difference between the groups. If the confidence interval does not include the null value, we infer that the group differs statistically. Because confidence intervals show the range of possible findings in the survey, they are vital to consider when generating data.
First of all is prediction modeling. Prediction modeling representation is a statistical approach used in finance, investment, and other fields to identify the strength and the type of connection between one independent variable, typically represented by y, and a sequence of other variables known as independent variable. This is a variable enter column. Simple linear regression and multiple linear regression are the two most common forms of regression, while non-linear regression methods exist for more complex data and analysis. Multiple linear regression utilize two or more independent variables to explain or predict the result of the dependent variable y, whereas simple linear regression uses one independent variable to explain or forecast the outcome of the dependent. Furthermore, the strength of the model's association with the dependent variable R or the multiple correlation coefficient denotes the linear relationship between the observed and anticipated values of the dependent variable. Its high value suggests a strong connection. This is the model summary. This is the normal P plot of regression standardized residual dependent variable of price. Here y can be the price of the species, x1 can be the weight of the species, and the x2 is the length of one of the species. And the conclusion. Researchers can use multiple regression analysis to evaluate the strength of the relationship between an outcome, the dependent variable, and several predictor variables, as well as the importance of each predictor to the relationship, often with the effect of the other predictors statistically eliminated. Multiple regression analysis, on the other hand, is a statistical procedure, not a study strategy, and hence does not demonstrate causality. This is because multiple regression is based on correlation, which only shows relationship between variables. Researchers must decrease bias induced by variables that cannot be discovered. For example, in order to demonstrate causal link, this can be accomplished through design either by modifying variables experimentally by employing statistical.
In short, we use data from a price captured at few places. We are required to analyze the data using the SPSS apps. We compare data and showing the result by one sample t-test, correlation analysis, confidence interval, and prediction modeling. We are learning a lot of new things while doing this statistic assignment very well. We work as team. We are glad after finish this task and hoping be able to practice this learning in the future. That's all from us. Thank you.